The question is to find out the optimum unit of labor. The question goes like this. The production function of a firm is x is equal to 5 times k to the power 1 upon 2 times L to the power 1 upon 2, where x is the output, k is the units of capital, L is the units of labor. Given capital is equal to 16 units, price of output is $6 and wage rate is $5 per unit. Find the optimum unit of labor. The options are 140, 142, 144 or 148. Okay, so what we are being given, let's rewrite it. So output is a function of 5 times k to the power 1 upon 2 L to the power 1 upon 2. K is fixed, which is being given as a 16, and price of x is equal to 6. Okay, we need to find out the optimum units of labor. For that, what will we do? First, we plug the value of k in this equation in the production function, that is x will be equal to 5. So we have 16 raised power 1 upon 2 times L to the power 1 upon 2. That gives us x will be equal to 5. Now 16 raised power 1 upon 2 is 4 times we have L to the power 1 upon 2, L to the power 1 upon 2. So our x is equal to 20 L to the power 1 upon 2. Okay, next thing is, what is the condition for employing the labor, the optimum units of labor? It is simple. To maximize profit, a manager will hire labor until the value marginal product of labor is equal to wage rate. That means, let me write it here. To maximize profit, firm will hire labor till or until value marginal product of labor is equal to wage rate, and wage rate is being given as 5 here. Now this value marginal product is simply equal to price of the product, this times marginal product of labor, and it should be equal to wage rate. So first we need to find out the marginal product of labor. Marginal product of labor will be simply the derivative of production function with respect to labor. Okay, taking derivative of this function with respect to labor, L here. So by power function rule, the exponent will become the coefficient. We have 20, L to the power, exponent will be subtracted by 1. Okay, so this becomes 10 L to the power minus 1 upon 2. So this is our MPL. So let's write it here. Price of x is being given as 6, so I can write here 6 times 10 L to the power minus 1 upon 2 should be equal to the wage rate that is being given as 5. So which implies 60 upon, if I transpose it here, it will become L to the power 1 upon 2. Exponent sign will get changed when we transpose numerator to denominator, should be equal to 5, which implies 5 cross multiplying. Okay, so we have 5 L to the power 1 upon 2 should be equal to 60. Let's rewrite it here. So L to the power 1 upon 2 will be equal to 60 upon 5. That gives us L raised power 1 upon 2 is equal to 12, or L will be equal to, if I transpose this exponent, it will remain exponent but reciprocated. Okay, so if it is 1 upon 2, it will become 2 upon 1 here. So L will be equal to 12 into 12 is 144. That means optimum units of labor required will be 144. Okay, this option.